So it is important that you have some idea about what is loopback interface and how do they work, and what is the purpose of loopback interfaces. So when we send a packet that is destined to a remote machine, what is the IP address we should specify as source and destination IP address? For example, in this topology, you can see that there are two routers or two machines, machine A and machine B. Machine A has two interfaces. On one interface, the IP address configured is 10.18.1.2/24 and the MAC address is MD and the name of the interface is Ethernet3. The second interface also has an IP address, the name as well as the MAC address. Similarly, machine B also have two interfaces on which IP address, MAC address and the name of the interface is configured. Now, you have internet in between. Having an internet in between means that the two machines A and machine B are separated, and in between there could be any number of L3 routers. Now, if A wants to send a data to machine B, what should be the source IP address to be specified in the IP header of the packet? Is the source IP address should be 10.18.1.2, that is the IP address of this interface, or 11.18.5.1, that is the IP address of second interface. Also, if A wants to send a data to router B, what should be the destination IP address specified in the IP header of the packet? Should it be 192.168.1.2, that is IP address of first interface of router B, or it should be 192.168.5.1, that is the IP address of second interface of router B. Now please note that as long as destination IP address is the IP address of any local interface of a destination machine, the packet will eventually going to reach that destination machine. It really do not impact any routing decision as long as the destination IP address specified in the packet is the IP address of local interface of destination machine. So A can specify source IP is equal to IP address of its any local interface. That is, it can specify the IP address of interface 1, that is 10.18.1.2, or it can specify the IP address of another interface 2, that is 11.18.5.1. Similarly, destination IP address could be the IP address of any local interface of machine B. So as long as this condition is satisfied, any packet that is generated by the router A and destined to machine B will going to reach its prescribed destination machine B as long as destination IP address and the source IP address in the packet meets the following criteria. In fact, the source IP address that is specified in the packet do not impact the journey of the packet to the destination machine B. It is only the destination IP address specified in the IP header of the packet that impact the journey of the packet from source machine to destination machine. So as long as destination IP address in the packet is the IP address of any local interface of destination machine, the packet will eventually going to reach destination machine. So let's call this rule as IP rule. Thus, any combination of source IP address, whether you specify the source IP address as 10.18.1.2 or 11.18.5.1 and destination IP address as 192.168.1.2 or 192.168.5.1, which are the IP address of local interface of destination machine, it would lead to the same result. That is, the packet would be delivered to B by the network layer. So are you a little confused here? Let me try to clarify more on this. So network layer view the addresses as some tags, as some sort of tags or labels that is attached to the L3 routers or the machine. Network layer is not aware that IP addresses are actually tied to interfaces. So network layer only view that router A has IP address 10.18.1.2 and this IP address is assigned to some local interface. Now which local interface? The network layer do not have this information. Similarly, network layer of the TCP IP stack only knows that the router A has an IP address 11.18.5.1/24 and it is assigned to some local interface of router A, but which interface this IP address is assigned? The network layer do not have this information. Similarly, router A only knows that the IP address 192.168.5.1/24 is the IP address of some local interface of router B. But to which interface this IP address actually belongs, router A do not have this information. So the network layer only view the IP address as some tags or labels that are the properties of L3 routers. So in other words, network layer only views IP addresses as some sort of tags or labels which are attached to the router, and network layer do not have any information about that to which interface the IP addresses has been configured. So there is a need to come up with a special IP addresses which identify the L3 router as a device. So we need to come up with the special IP addresses which actually identify the L3 router as a device, and it should be unique in the network. That is, if somebody says you, hey, the IP address of router B is 122.1.1.1, so it should mean that 122.1.1.1 is mapped to the router B instead of to some local interface of router B. So 122.1.1.1 should identify the router B. So it should identify, like you are identified by your name. Similarly, there is a need of some special IP addresses which identify the device as a whole. So loopback 0 addresses helps achieve this goal. Loopback addresses are the identity of a routing device. So let us discuss the properties of loopback IP addresses and loopback interfaces. So only interfaces have IP addresses, not machines. This is true. It is only the interfaces that have IP addresses. Machines do not have IP addresses. We will discuss this point more when we say, hey, some machine XYZ has an IP address blah blah blah. What does it mean? It means that that particular machine XYZ's loopback address is blah blah blah. So coming to the second point, but there should be some way to identify the machine uniquely through IP address in the network. For this purpose, we create a special software interface. Note the word, it is a software interface called Loopback Interface on the machine, and we assign IP address to it. So loopback interfaces are actually the software interface. It means loopback interface are not hardware. Now, suppose you have a router, you have interface I1, you have interface I2, you have interface I3. These interfaces are used to transmit and receive the packets or data. So these interfaces are actually hardware. You have to buy the hardware to insert them as an interface in the router. So these are actual hardware. You have to buy these pieces of hardware from the market. These are called network interface cards, NIC or NIC. Loopback interface, on the other hand, is a software simulation of an interface. In other words, it's a software interface. That is, somebody has write a program and that program creates a virtual interface. That is the interface which do not have a hardware, but the operating system sees loopback interface as like any other physical interface. But actually that loopback interface is a virtual interface or a software interface. Loopback interface doesn't have any hardware attached to it. That is the reason that loopback interface are not used for any traffic reception or traffic dispatch, or in other words, loopback interface are not used for any data exchange because they are actually not a hardware. So that is the reason that loopback interface are software interface. Now, since loopback interfaces are software interface, you can create as many loopback interfaces as you want. You don't have to buy loopback interface from the market because these are software based interface. So loopback interface is not a hardware but software based interfaces, and therefore you can create as many as you want. Loopback interface are one-ended interface, they don't have other end. We will elaborate more on this later. For now, just keep in mind that loopback interfaces are one-ended interface. These interfaces do not have the other end. Hence, every loopback interface is one entire subnet with one machine in it. Therefore, loopback addresses have mask 32. So, in the next slide, we will discuss these 2 points more elaboratively. Loopback interfaces are not prone to hardware failures. Why they are not prone to hardware failures? Because they are not hardware in the first place. They are software-based interface. And because loopback interface cannot fail, therefore they show the property of high availability. Now, if router A creates a loopback interface, say LO1 with IP address 12.1.1/32, and B creates a loopback interface with IP address 13.1.1/32, A can send packet to B with source IP address 12.1.1/32 and destination IP address 13.1.1. Also, note that IP rule is still valid. Why IP rule is still valid? Because at the end of the day, loopback interfaces are also local interfaces. So as long as you are specifying the IP address of any local interface of a source machine or the IP address of any local interface of a destination machine, the packet will going to reach the destination machine. So IP rule is still valid. It's just that it's a good practice to specify the source IP address and destination IP address as the IP address of loopback interfaces. Now, if source machine assigns source IP address is equal to IP address of any local interface and destination IP is equal to IP address of any local interface of destination machine. No, not destination machine, sorry. Destination IP address is equal to IP address of any local interface of a source machine itself. That is, suppose there is a router A, it has 2 interfaces. On the interface 1, it has an IP address A, and on the interface 2, it has an IP address B. Now, if this router tries to send a packet with source IP is equal to A and destination IP is equal to B, what will happen? That is, the router is trying to send a packet to itself. So in such a case, what will happen? That the packet will traverse down the TCP/IP stack as usual on source machine. That is, remember the TCP/IP stack and the outgoing journey of a packet in the TCP/IP stack. You have a transport layer here, and then you have a network layer here and the data link layer. So the packet will move down from the application layer down the TCP/IP stack. But since the packet is destined to self only, what will operating system do? Operating system will reroute the packet back to self. That is, the packet will reroute back on the same machine just before the packet is placed on the wire. The packet then traverses the ingress journey. That is, this is the ingress journey of the packet, and this was the egress journey of the packet. This is ingress journey, and this was egress journey of the packet. So the packet then traverses the ingress journey as though it arrived from the remote machine. Using this logic, network applications can be developed and tested on a single machine. And these are not those network applications which are designed to interact with various other network devices deployed in the network. But using this knowledge, you can actually develop the network applications on a single machine. You need not have 3, 4, 5 or 10 machines in the network in order to test your network application. It is a good practice to assign source IP is equal to IP address of loopback interface of source machine and destination IP address is equal to IP address of loopback interface of destination machine. Loopback interfaces are not used for any traffic exchange. Why they cannot be used for any traffic exchange? Because loopback interfaces do not have a peer. Loopback interfaces are not connected on the other side. In fact, loopback interfaces are not physical interfaces. If they are not physical interfaces, they cannot exchange any data. They are software-based interfaces. At the end of the day, you need a hardware, you need a wire to exchange the data. And this is what loopback interfaces are not. Loopback interfaces are not wire, or they are not physical interfaces. They are just a piece of software which is simulating as an interface. Therefore, loopback interface serves the purpose of device reachability in the network. Device reachability means you can always ping the device deployed in the network using its loopback interface. Because loopback interface is expected to be always up and running. Because loopback interface is not tied to any piece of physical hardware. That is why loopback interface is expected to be failure free. Hardware can fail, software cannot fail unless hardware is failed. Going forward, view loopback interface as just another interface connecting to a subnet which can contain maximum of one interface on a machine as shown below. So here you can see a router which has 3 interfaces. So interface 3 and interface 2 are just normal physical interfaces. And on this interface, if it is a point-to-point link, you can have another router here. And if it is not a point-to-point link, then you can have some set of host machines connected on this wire. Same is true with respect to other interface of this router. But the third interface is loopback interface. You can see that the loopback interface also has a MAC address. It also has a name. It also has an IP address. But for loopback interfaces, there is no peer. That is, you cannot have any host machine connected on the other side of a loopback interface. Reason that loopback interfaces are not physical interfaces, they are not wire, they are not physical interfaces, they are just software based interfaces, and the operating system sees loopback interfaces like any other physical interfaces, but loopback interfaces has the property that they are not physical interfaces, they are not used for data exchange, they do not have a peer, that is, it do not have any machine connected on the other side of the interfaces because they are software based interfaces. So let us do a little exercise here. In our example, create a loopback interface LO1 on all VMs and assign IP address to it. So from the terminal, using this command line, you can actually configure a loopback interface. So the command is sudo ipconfig loopback interface : and you have to supply some number. So it is LO:1. It is the name of the loopback interface. Assign an IP address to this interface and loopback interface always have a mask value equal to 32, and the state of the loopback interface is up. So if you configure a loopback interface using command line, on reboot, this loopback interface will disappear. So to permanently add the loopback interface, you have to modify the file etc network interfaces, and you have to do this entry. Create a loopback interface hello colon 1. Tell the machine that you are going to configure the static IP address on the loopback interface. Assign the IP address to the loopback interface. Assign the network ID to the loopback interface, that is the network IP address, and the mask value of the loopback interface. Now, I have one question. Suppose you have created a loopback interface LO1 and you assign the IP address to this loopback interface, which is 122.1.1.1/32. Now, let us revise how to calculate the network ID. What will be the network ID of this IP address? What will be the broadcast address? Now, if you apply the mathematics that we have learned in the previous lecture for how to calculate the network ID and broadcast address from a given IP address, you will find that the network ID for loopback interfaces is equal to broadcast address for loopback interfaces is equal to address of loopback interface itself, which is network ID will be 122.1.1.1/32. This will be network ID, and the broadcast address will be 122.1.1.1/32. So in case of loopback interfaces, the network ID and the broadcast address and the interface IP address itself are same. The reason being that the loopback interface is a subnet in which only one machine is possible, and that machine is the router itself on which loopback interface is created. So coming back, now you know how to configure a loopback interface on the router or on your VM. So in this topology, you have 4 VMs. On each of the VM, configure the loopback interfaces as follows. Now, once you configure the loopback interfaces on all four of your virtual machines, now we have already discussed how to install the routes in the routing tables. So, as an exercise, you need to install appropriate routes in the routing tables of all VMs so that we can ping loopback addresses of any VM from any other VM. Loopback addresses are always like remote subnets, right? So loopback interface are always like remote subnets means. Let me clarify more on this point, that what we mean by loopback interfaces are always like remote subnets. For a machine VM, the loopback IP addresses of machine VM1, VM2 and VM3 are all remote subnets. Similarly, for machine VM1, the loopback IP addresses of machine VM, VM2 and VM3 are remote subnets. And this is true for virtual machine VM2 as well as VM3. Why they are remote subnets? Apply the definition that. So we learned how to decide whether a given subnet is a remote subnet or a local subnet. So let us talk about virtual machine VM as well as virtual machine VM1. Now VM1 virtual machine has a loopback address 10.0.0/10.0.02/32. Now apply the definition of deciding whether a given subnet is a local subnet or remote subnet. Now for the machine VM, is there any local interface of machine VM which has an IP address which falls in this subnet? The answer is no. It means that the loopback interface of virtual machine VM is a remote subnet with respect to virtual machine VM. So I'm not saying anything new, I'm just applying the older definition, the older basic definition and principles in order to arrive at a conclusion. Similarly, virtual machine VM1, is there any local interface of virtual machine VM1 which has IP address such that that IP address falls in the subnet 10.0.0.1/32? The answer is no. So that is the reason that loopback addresses are always remote subnets with respect to any other machine in the network. Loopback addresses are always remote subnets.